In Creo Parametric, you can make standard components like sprockets. I found instructions for creating a sprocket online at instructables.com. I will put the link on the screen and in the description. I decided to duplicate those steps that were written for AutoCAD in Creo Parametric. So here's my end result. Let me show you how to do it. I'm going to start off by creating a brand new part. I will click on the new icon. Here we have part selected, and later on I'm going to use this for creating a family table. So I'm going to call it Sprocket Generic, and I'm going to make sure that I'm using one of my default templates that is in inches. This one is good. Let me click the OK button. And here I have my new part started. Let me turn on my datum plane display. And one thing that I am going to do is change my accuracy, because I'm going to be working in very small values. And so I'm going to make sure that my numbers are capable of regenerating. And next, I am going to create a couple of parameters that I will use in relations later on in order to drive the geometry. Then I can use those different parameters in a family table. So here I am. I went to the relations dialog box by accident, but that's okay. I can create parameters from here. And so the first parameter that I am going to create will be for the pitch. So let me type in the name, and this is going to be a real number. I will start off by making the standard 40 chain sprocket. And so this is going to have a value of 0.5. And in this particular case, let's even define a quantity for the parameter. I'm going to use length. And since my model is in inches, it automatically defaulted to inches. Let's create another parameter. And this one will be for the roller diameter. And once again, it is a real number. And this value is going to be 0.313. And once again, I'm going to add a unit quantity for length. Not really necessary, but hey, why not? And then another one that we're going to have is going to be for the thickness of the sprocket. And that is going to be a value for this one of 0.284. And yeah, let's go ahead and define a unit quantity. And the last one for now is going to be for the number of teeth. And I'm going to change this to an integer, make it a value of 40 teeth for this particular sprocket. That's good. And let me take this one. I have this old parameter, this old relation for calculating a weight parameter. I really don't need it anymore. Let's click the OK button. And now I am going to start creating the sketch for the tooth. Let's select the plane called front and then hit the sketch icon. I'm going to use the icon in the graphics toolbar to change to looking straight on at the model. Let me zoom in a lot because I know I'm going to be dealing with some small values. And the first thing that I will create is a line. I'm going to create it as a regular line to begin with. And this one needs to be half the length of the pitch. Let me change its value. And right now it's got a really big value. Let me change this. My pitch is 0.5, so this needs to be 0.25. And let me refit to the screen. Let's drag that dimension, move it in a little bit closer, and turn off my datum plane display. So that's the first entity that's going to be in here. The next one is going to be a line, or rather a center line. Let's go to center line, and we're going to create a center line here, and then over here. And let's put in our dimension. It's going to be the angle from here to here. Locate your middle mouse button between the two lines and then middle mouse click. And this one is going to be 360 divided by the number of teeth times 2. In other words, a value of 4.5. And again, later on, I'm going to write relations so that the entities in the sketch are driven by these different dimensions rather than the numbers that I am clicking in here. Let me grab the dimension and move it a little bit to the inside. I am not writing relations in the sketch because that can cause some issues later on. And so the next entity that I'm going to create will be a horizontal line, and it will snap right into my center line. Again, later on, I'm going to turn all of this stuff into, or most of this stuff into construction geometry, but not at the moment. All right, now that I have this, we are going to create a vertical line, and the length of this line is going to be the pitch. Let's change this to a value of 0.5. And then we're going to make two circles that are going to be located at these two different points, and it's going to have the diameter of the roller diameter plus a little bit of tolerance. So let's go to the circle command and create a circle over here and then a circle over here. I will let it snap to being equals, and the dimension for this one is going to be 0.318. Again, that's just an initial value, and later on it's going to end up changing. The next step that is recommended in the procedure after we have these different entities is to then go about putting in a line at the tangents here. So I'll go to the line drop down and change to line tangent, pick one circle and then pick the other circle. That's good. This line is not going to be needed, but rather than delete it, I'm going to turn it into construction geometry by using the icon in the mini toolbar. Now we need a couple of other additional lines located at 20% and 60% of the pitch. And so to facilitate that, let's throw in a couple of sketch points. I'll put in a sketch point here and a sketch point over here. And let's then put in some dimensions. I will dimension from here to here and then locate the dimension over there. And again, this is going to be 20% of the pitch, which is 0.5. So in other words, this dimension is going to be 0.1. And then the distance from this point to this entity, let's locate the dimension over here. This is going to be 60% of the pitch. My pitch is 0.5, so this will be a value of 0.3. And we've got this one dimension in the way. Let's move it out of the way for a moment. So now that we have these two different lines here, we are going to create a horizontal line. Let me change from line tangent to the regular line. And I'll let it snap into the points where it's supposed to be. And so this little segment in here, this is going to end up being one of our main regions that we use for extruding the shape of the tooth. But anyhow, let me then go about. So let's see, we're also going to create another line, and this other line is going to be a width of 10% of the pitch. Let me zoom in over here. And again, all these instructions are online. You can follow what the gentleman has put in there. I will let it snap to midpoint. And this is, again, is going to be 10% of the pitch. So in other words, this is going to be a value of 0.05. Adjust the length. Let me move the dimension. All right. So now that we have all these different entities in here, in the instructions in Instructables, they go about deleting a bunch of different segments, but I am going to instead divide them and turn this into construction geometry just so that it is still available as a visual reference. Let's go to the divide tool, and I'll choose divide here and here and here. And then before I do that, let's select this line and turn that into construction. And let's then go to the divide command and divide here. So now I should be able to select this entity and turn it into construction. And same with this entity over here, turn it into construction. And there you can see we have shading, so this is forming a closed loop. The next step is to create an arc from here to here. and it's also supposed to be tangent here, I believe. So let's go to our arc. I'm going to create a 3-point tangent and arc. And here's one of the interesting things about the arc command. I always fail to memorize this, but if we click on the one location, then you're going to get this green, what they call a target circle. And where you move your mouse out of the target circle depends on what kind of arc that you're going to get. And if I go out horizontal and then pick another point, here we can let it, come here. There we go. Snap to tangency on that one. And I got it to the wrong location. So let me delete that and try again. Let's create our 3-point tangent arc. Click the end point and go out sort of like horizontal. Nope, got it wrong. Let's go out not horizontal and keep on almost getting it. There we go. There we go. That is the arc that we want. Then I can select the arc and then mirror it about my construction line. And there we have the entities there. Let's now select this line and turn it into construction geometry. And there we have the shape of the tooth that they want. Beware in the instructions in the web page on Instructables.com, they put the fillet in here. They recommend putting in 8% of pitch. When I did that before, it ended up causing an error when I tried to extrude or generate because it ends up intersecting itself. So later on, I'm just going to put in a full round. But this is going to be the shape of the entity. One other thing that I am going to put in is that the diameter of the circle that this is going to be attached to is going to be out to this location. And so I am going to give myself a reference for that. I'm going to create a sketch for another circle in a separate feature just to keep everything easy. I've got this one other line over here. Let's turn it into construction geometry. So this sketch has everything for our tooth, but let me put in a point over here just as a reference later on for the next sketch. So let's hit the check mark and let me bring back my model tree. And this, I'm going to rename this to be called my tooth sketch. And let me create another sketch. And I'll choose use previous for the same references. And for this one, I'm going to create my circle. Let me turn on my point display and create the circle from here and let it snap into that point as the reference and then hit the check mark. And so now that I have my circle for my main disk, hey, let's be consistent. Let's rename this one. Let me click on it. And this will be my main circle sketch. So now I can select the sketch and we're going to extrude it and we're getting a really big value. Let's change this to symmetric, and actually I chose the wrong option. Let me change this to symmetric. There we go. And this one is going to be what? Something like 0.284. I'll write the relations in later on. So that's going to be our main disk. Let's hit the check mark. And then for the next one, let's select our initial tooth sketch and extrude this one. And let me choose to make this one symmetric as well. And I'll use the same depth. And again, I'm going to write in some relations later on to drive everything by it. I'm hitting all the wrong buttons today. So that's good for our first tooth. Let me turn on my axis display, and then I will rename this to be my tooth extrude. Let's try putting in our full round. So I will go to the rounds tool and I will select one edge and then this other edge here. And let's change this to a full round and everything looks good. I will hit the check mark. And so that is a little better than plugging in a number that I find. So now that we have these two features, I can select them and group them. And then we can click on the group and then use the pattern option. By default, we're getting a dimension pattern. I can use the right mouse button to change this to an axis pattern and then pick the main axis. And let's choose angular extent 360 degrees, number of instances. I'm going to plug in a value of 40 and later on I will change this to a relation. Let's hit the check mark. And now we have all our different sprockets in here. Let's create a center hole as well. I will go to the hole command and then select the axis. And then let me hold down the control key to select the disk as the starting surface. Hole diameter is ginormous. Let's drag this down to a value. Let me use a value of 1 inch. And then for the depth, let's change this to next and hit the check mark. Turn off the axis display and the point display. And there we have our sprocket created. Now I want to make sure that everything is driven by those different parameters. So let's go to our relations dialog box and move it over to the side just so I can see everything. Let's start by going to the tooth sketch. We've got a number of different dimensions in here. And so let me go to a blank line and you can either pick the dimensions on the screen or type them in manually. So D0, this is going to be equal to, and you can either type in the name of the parameter manually, or if you want to be lazy, insert parameter from the list. Then I can select pitch, insert selected, and this divided by 2. I really didn't save myself anything by doing that. The next one, this D1 dimension, this is going to be equal to 360 divided by the number of teeth times 2. And let's see, let's continue on in here, taking a look at everything. This dimension got turned into a reference dimension. I don't see the other dimension in here for the pitch, but later on I could tackle this. Let's see, we have the D3 dimension. Let me go to a blank line. This D3 dimension is going to be equal to roller diameter plus 0.005. And let's see, this dimension, the D4 dimension, this is going to be equal to the pitch times 0.2. The D5 dimension is going to be equal to the pitch times 0.6. This D6 dimension, that's going to be equal to the pitch times 0.1. And later I can go back and see if there are any other ones that I am missing, but I think I got most of the different dimensions in there. Let's click on the OK button, and actually forgot a few other different relations to write in here. Let's go back to the relations dialog box. Let's go back to relations and then go to a blank line. And so let's see, for extrude 1, let me find the thickness dimension. Looks like it's D7. This D7 is going to be equal to the parameter that I called thickness. Let me repaint the screen just so that nothing's showing up. Let me expand the local group, the first local group, and let me go to tooth extrude. I really could do this extrude using depth options of 2 selected for the different faces. Looks like it is the D9 dimension for this one, and this one can also be equal to the thickness. And lastly, once again, let me repaint so that we don't have anything on the screen. If I select the pattern itself, it's the P22 dimension here. Let me go to a blank line. This P22, this is going to be equal to the number of teeth. And so in this way, I have my model being driven by these 4 different parameters. I change these different parameters, and then my model is going to update. Let's click the OK button and repaint the screen. And so in that way, we've created our sprocket with our 4 different parameters, which I can then use to drive a family table. And so there you have it, the design of the sprocket based on the information from Instructables.com. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.